Hello dear fellows, today we will see the ProtParam tool, which is used for the analysis of physicochemical properties of mutated proteins. ProtParam is a tool which allows the computation of various physical and chemical parameters for a given protein for a user entered protein sequence. The computed parameters include molecular weight, theoretical pi, amino acid composition, atomic composition, extinction coefficient, estimated half-life, instability index, aliphatic index, and grand average of hydropathicity, which is abbreviated as GRAVY. You will search it on Google and click on the ProtParam tool. This will show us the home page of ProtParam tool, which is giving you two options in the form of two windows. One window is small and one is large. The smaller window is to provide the accession number of your protein, and the larger one is for the sequence. As we have designed multiple cases, and in each case we have incorporated our mutation, which is in some cases it is a missense mutation, or in other it is a stop gained, or it may be frame shift mutation. So we cannot use the accession number. We will directly paste the CDS of our normal protein, or if you want to see the change in the properties of a protein in response to mutations, then you will paste the sequence of the mutated CDS, and then we'll click on the compute parameters. This will show you the results in detail, and the first at first you will see the sequence which you have provided in the window, and it is showing the numbering, the amino acids with the numbering, and after each 10 amino acids they have numbered, they have given the number, and below this sequence you will be able to see the number of amino acids, and then molecular weight, theoretical pi, and the amino acid composition, in which the number of each amino acid and the percentage of each amino acid with respect to the total amino acids in the protein is given. And below you can see the total number of negatively charged residues and the total number of positively charged residues. Then there is atomic composition, that is the number of carbon, hydrogen, nitrogen, oxygen, and sulfur atoms in your protein. And below it the formula is given, the total number of atoms are given, and then there is extinction coefficient. Extinction coefficients are always expressed in per mole per centimeter units, and we will see two different values for the extinction coefficient. One is obtained while assuming all pairs of cysteine residues from cysteines, that is non-reduced forms of cysteine residues, while the other extinction coefficient will be shown while assuming all cysteine residues to be reduced. So it's up to you which value you want to select and show, and it will be followed by the estimated half-life of your protein, and the half-life of three types of protein will be given, like one for the mammalian reticulocytes in vitro, other for yeast in vivo, and third one is E. coli in vivo. Now if you have pasted the sequence of mammalian protein, then you will follow this value, which is in this case 30 hours. If you are going to paste the sequence of yeast, then you will follow this value, which is here more than 20 hours, and so on. Then there is an option of instability index. The instability index value is given, which is followed by the aliphatic index value, and then there is the value of GRAVY. Now let me explain that how you will arrange the results of ProtParam analysis in tabulated form after retrieving them from the ProtParam tool. The first column would be the case ID, in which always represent the in the representation of any of the results from your analysis, you are supposed to mention the results for your normal protein in the first row, because it will enable you to compare, to make a good comparison between the normal protein characteristics as well as the mutated protein characteristics. And in rest of the columns you will represent your cases like case 1, case 2, case 3, and so on. In next column you will show number of amino acids, and then molecular weight, then theoretical pi or isoelectric point, and then estimated half-life, instability index, aliphatic index, extinction coefficient, and then there should also be a column of gravy, which I forgot to insert in this table. And now what does the instability index show? Instability index is a measure of stability of the protein in a test tube. If the index value is less than 40, then it means that the protein is probably stable in the test tube. And here you can easily compare the instability index of your normal protein with the mutated proteins, and this will make you realize or interpret that how your inserted or incorporated mutation has altered the overall instability or the stability of your protein. Like as I mentioned that if it is less than 40, then the protein is stable. Now you can see here in case of normal protein the value is 31.19, which is showing that your normal protein is unstable in vitro, while in case 1 you can see the value has increased. It means the mutation which has been incorporated in case 1 CDS has increased the in vitro stability of your protein with the value of 51.45. The next parameter which you have computed through ProtParam is aliphatic index, and it is showing the relative volume occupied by the aliphatic side chains, and it is contributed by the amino acids like alanine, valine, isoleucine, and leucine. It may be regarded as a positive factor for the increase of thermostability of the globular proteins. Like here you can see in aliphatic index that our normal protein has highest value of aliphatic index, which is 83.91, and it is showing that it is very much thermally stable. But in case 1 you can see here the value has reduced to 54.86. It means that this mutation has decreased the thermal stability of the protein, while the mutation which is introduced in case 2 has very slightly affected the thermal stability of the protein. The next parameter is extinction coefficient. It shows you how much light a protein absorbs at UV wavelength of 280 nanometer, and its value depends on the number of absorbance at 280 nanometer of the absorbing residues like tyrosine, tryptophan, and cysteine disulfide bonds. You can also compare it between the normal and the mutated proteins. Then there is gravy. Gravy number of a protein is a measure of its hydrophobicity, and it calculates the sum of the hydropathy values of all the amino acids divided by the sequence length. Suppose if you get the value of gravy in positive, then it shows that your protein is polar, and if you get the value in minus, then it shows that the protein is non-polar. Like here in case of normal protein, sorry, I have not given you the examples of gravy in this table, but it is very easy to interpret. If in case normal protein is positive, showing positive gravy values, then it means it is polar, and if your mutated protein is showing the negative value, it means that the mutation that is incorporated in that case is actually making the protein non-polar. Thank you so much.